Hello again, and welcome back to Educator.com's Advanced PHP with MySQL course. In today's lesson, we're going to be talking about what's known as a linking table, which is a type of table in a database that's going to allow us to move our departments database from a file-based system over into our MySQL database. We're going to talk about the concepts of how could we model our departments in a database table, which is going to lead to our discussion, basically progress us forward into this discussion of linking tables, which is sort of the goal of this lesson. As part of that discussion, we're going to be talking about a concept called database normalization, which is a way to basically make your database work and act more efficiently. One of the topics related to that is something known as foreign keys. Then we're going to talk about what a linking table is, and also related to a linking table, how you can have a table with a primary key that's comprised of multiple columns. Then we're going to go over required homework that you're going to need to do to basically set up your advanced PHP database so that you can run the future versions of our sample web application. So basically, we know that a department object from our web application we know that the object itself has three properties. It has a department ID, a name, and then it has an indexed array of item IDs, where each item ID represents an item in a department. So how could we model this in a table? There's a couple of different things that we could do. For example, we could create a table with that maps one column to each property of our object. We could have a column called department ID, which would be the primary key of the table. It's a unique ID for each department. We could have a column called name, which would be the name of the particular department. And then we could have a column called items, which would be used to hold the information about all of the different items that are in a particular department. In this case, as has been the case in our departments.txt file, we've been basically storing all of the item information in a comma delimited list that basically shows all the items in the particular department. So we could simply just move that comma delimited string into this items row, into this items columns of our department table. So here would be a department with 3 items, and here would be a department with 2 items, for example. The problem with that is, that we're going to talk about in the next slide with database normalization, is it makes it difficult to search the database. One of the reasons we use a relational database is because of the way it can quickly search information. Well, now in order to look up an item to see if, for example, item 1004 was part of department number 1, we'd actually have to pull this column up using a select query from the database and then parse through that as we had been doing in our departments.txt file, basically extracting each of the items IDs in that using, for example, the explode function that works on separating items by the comma delimiter, and basically it just adds another step. So it takes away our advantage of using the database to automatically search for things. Now we have to write some manual code to basically parse that item string. So another option you might think would be, let's have a department ID column again, a name column again, but then this time we just create a column to store each item's, a column to store the item ID of each item in the department. So we'd have a different column for each item in the department. So we might have one called item ID 1, item ID 2, and item ID 3. In this particular case, the first item, if it was the same exact data as up here, it would have 3 values, 1001, 1004, 1007, and so all of those columns would be filled up. However, our electronics department only has 2 items, so it has this empty column here. Well, let's say right now basically this limits us to only having 3 items in our database. So if we wanted to be able to have a fourth item in the department, we'd have to add another column over here, which is going to involve restructuring our table, which is a procedure you want to avoid if possible. Additionally, if we add a 4th item, for example 1008, to our first department, and it still only has 2 items for department number 2, now we have 2 empty spaces in our database. And so this is stuff that takes up space in our database, and basically one of the goals is you want to avoid having a lot of empty space within your database. So that's going to bring us to the concept known as database normalization. And basically that's a process, sort of an iterative process in a way that you go through to basically structure your relational database to help reduce a number of these problems we've been talking about. We talked about the difficulty with searching data. If we it's under the concept called of atomic values. Basically, in that first table that we had, where we had basically 3 item IDs all in one column, that's considered non-atomic. Atomic means a single value. So basically, we had 3 values contained in one column, which makes it difficult to search. If we have only 1 item ID in each particular column, that's known as an atomic data value. It makes it easier to search. So database normalization is going to help us change the structure of our table so that searching is easier. It's going to avoid having a large number of empty fields. We saw, for example, in the second table that we had, where let's say we have a new column for each item so that we can have up to 4 items. Well, if one of those departments only has 1 item in it, it's going to have a lot of empty columns, and that's something we want to avoid in our database. So normalization is going to help with that. It's also going to avoid the problem of having to restructure our tables frequently. As we saw before, our table, the second table originally started, we were only able to have 3 items in a particular department. Well, ideally, we'd like to have as many items as we want in a department, which means every time we wanted to add an additional item to a department, let's say right now our database was enabled a department to hold 5 items. Well, now maybe we want 8 items in there. Well, we have to restructure our database, and we have to continually do that. So normalization is going to help us avoid having to do that. And then something else that wasn't mentioned on those other slides that it's going to help us avoid is something called data redundancy. Let's say, for example, we had a table called orders that represents all of the orders, an order that, excuse me, that a user places on our web store. Well, maybe we have a primary key for the orders table called order ID, which is a unique ID for that particular order. We would store the amount of the order in a column. We would store the customer's name, and then their city and state. And we'd probably have more information here, like address, apartment number, and stuff like that, but because of the size of the slide, we're just going to limit it to this. But I think you can see the point. So let's, for example, one of the things about having customers on our website is, or people placing orders on our websites, is we might have the same customer place multiple orders. And that's something we would want. So for example, let's say our first order was placed by Joe Smith from Houston, Texas for $150. Then Jane Jones comes along and she places an order for $200, and she's from Boston, Mass. Joe Smith comes back to our web store. He says, I like this store. I want to buy something else. So we add another row to our order table. It's going to have the amount that's ordered, and then it's going to have Joe's name and his address again. Well, this right here is redundant data. That, assuming it's the same customer, because there could be 2 Joe Smiths from Houston, Texas, we basically have that same data in our database twice. So for example, let's say we wanted to update Joe Smith's address information, and let's say it was stored in this orders table. We'd have to go through and we'd have to update this row here, and we'd have to update this row here. Maybe he becomes from Boston, Mass. So now, because we have the same data in multiple spots, we have to make multiple updates. And also what it does is basically now we have, this information that's stored in our database takes up space on a server. This data is stored in memory somewhere. So we have the same data stored in 2 different spots, when really we could have it stored in 1 spot, which we're going to see on the next slide. And theoretically, maybe Joe could place 10 different orders. Now we have the same information in 10 different spots within our orders table. We have the information repeated multiple times, and then anytime we wanted to go and update it, we have to update it in multiple spots as opposed to 1. Well, there's a way we can improve on that. And it uses a concept known as a foreign key. Basically, what a foreign key is it's a column in one table that refers to the primary key column in another table. For example, let's say we changed our orders table so that it would just have the order ID, it would have the amount, and then it would have this other column called customer ID. And you can see that it's in italics. Typically, italics in these sort of database descriptions represents a foreign key. And what this customer ID is going to do is it's going to refer to the primary key of a row in another table. So for example, if we instead move all the information about Joe Smith and Jane Jones into its own customers table, we can create a new table called customers that has a unique ID for each customer, which would be the primary key of that table. And then it has columns for their first name, their last name, their city, and their state. So now what we can do is, instead of having to have Joe Smith from Houston, Texas written out here and here in our orders table, we simply can use the primary key ID from the customers table And basically what that's going to do, and we can insert it into this foreign key column of our orders database. Basically what that's going to do is that's going to link this order to Joe. So now basically what we have is we have Joe Smith's information, but instead of having it twice in the table, by linking, having his customer ID in two spots in this customer ID column of our orders table, they both can link to the same spot. We have it in one place. If Joe changes his address, we only need to update it here. Additionally, we don't have that in two different spots. So that's what a foreign key can be used for. One thing to note is that if you're going to use a foreign key, which again is a value that represents a primary key and another ID. So we know a primary key value indicates a unique row in a table. So this, if it's a foreign key, it's going to indicate a unique row in another table, in this case a unique row in customers. You just have to make sure that the data types match up here. So for example, if this was if the customer ID primary key column of our customers table was an unsigned int, then you'd want the foreign key column to also be an unsigned int. You would want it, for example, to be a varchar. So you want the types of those to match up. And so that's how a foreign key can basically be used to link one row in a table to a row in another table. We're going to expand on that a little more to come up to the concept that this lesson is mainly about, or the ultimate goal of this lesson, which is known as a linking table. Basically what a linking table is a table that contains that each row of the table contains two or more foreign keys representing rows in another table. So let's best probably explain by an example. Let's say we create a departments table, and this is sort of the goal of this lesson, is we're trying to efficiently model our departments table in our database. And as we saw earlier, the way we were doing it in the first slide, it wasn't really an efficient method, and we saw from the rules of database normalization that there were a lot of problems with that. This is a solution that's going to basically solve that problem. Let's say we create a departments table that instead of having an items column, it's just going to have two columns, a primary key column for department ID and then the name of the department. Well, we know also that we have an items table in our database that has a primary key item ID, has a name, it has a price. I've left off the rest here just so this would fit on the slide. But basically we know that we can identify an item in the item table by its primary key. Similarly, we can identify a department in this departments table by its primary key. Well, now what we can do is, in order to add items to a department, is we can create a linking table, and in this case it's going to be called departments underscore items, and that's typically the case for linking tables. Is the name of the table contains the names of the two tables we're trying to link together, and what we can do is for each item in department 1 we can add a row to this table. So we can say department 1 contains item 1001. Now department ID 1 is a foreign key that's going to refer to the primary key of the departments table. Item 1001 is a foreign key that's going to refer to item 1001 in the items table. Now what we can do is continually add for each item in the department. We want to add item 1004 to department number 1. We simply create a new row that has the department ID of the item we want to add to and then the item ID. The same thing we can do for department 2. We can add 2 items to it as well. Now what this allows us to do is now we can add as many items to a department as we want. So we could have department 1 have 4 different items in it, whereas department 2 only has 2 items in it. That's going to keep us from having to restructure this department table by maybe adding a new column every time we want to increase the capacity of the number of items of a column. Additionally, it reduces the space, empty space in a table that would be stored for item 2, whereas it only has 2 items. If we had a table that would allow 4 items to be in a department, there'd be, for department 2, the row for department 2 would have 2 empty spots in it. So we've eliminated that empty space that's not needed, and then also we've allowed our application to grow to where we can put as many items in a department as we want without having to restructure our particular table. And so this is how we're going to model our departments in our database. We're going to create this departments table that's just going to have the ID and the name of the department, and then we're going to have this separate linking table that we're going to use to link to basically add items from into a department. And basically the way we do that is we use the primary key of the department ID and the primary key of the item ID we want to add to it and put those in the same row in this department items table. And again, these are both, you can see they're italicized here, these are both foreign keys because they refer to primary keys in another table. So this row right here again is going to uniquely link one row in our department table to one row in our item table, one row in our department table to one row in the items table, and so forth. So as we know with our tables, we want to have a primary key for our table. And what we're going to explain now is that in that departments underscore items table, our linking table, it's actually going to have a primary key that's composed of two columns. So we know that a primary key is used to uniquely identify a row in a table. Well, if we know that, let's say, each store item, let's say we have the rule, which would make sense, that each store item can only be in a department once, then what that's going to say is that in our departments underscore items table, each department ID can only be matched up with an item ID one time. So each of those pairs is unique. Now, because they're unique and they are the row of the table, we can use those to uniquely identify a row in the table. We can say, I want the row from the table that has department ID number 1 and then also has item ID 1001 with it. That way we can uniquely locate that row in the table. So we have, basically we have a primary key where the key of the table involves two different columns. So for our linking table, both of those columns, department ID and item ID, are going to comprise the primary key for that table. Now the way you do that, the syntax for that is in our create table SQL statement, we define our department ID and item ID columns as we normally would, any other column. Notice that we have the type int unsigned, and here, because this is a foreign key that matches a key in another table, we want it to have the same data type as the other table. Well, in our department table, you'll see in a minute, we're going to create department ID as an int, unsigned int, and we know from our item ID table that it's an unsigned int, so we give both of these data types unsigned int. And the way we signify a multiple column primary key is by adding after all of our column definitions this phrase key, primary key, and then we include in parentheses a comma delimited list of the different columns that we want to use to represent the primary key for that table. What this is going to do is if, let's say we have, let's say this is some data from our department's items linking table. Basically, when we define this as the primary key, this is going to let MySQL know that each of those pairs of department item and item ID have to be unique. And it'll help us to enforce the fact that only one item is in a department. So if we try to, for example, run an insert statement, and I'm just going to abbreviate it, with the values 1 and 1001, MySQL is going to complain and say they can't be that primary key, a row with that primary key already exists in the table. And so that's going to allow us to be able to enforce that. So let's go ahead and basically run the code, or run these create table scripts that's going to set up our departments, the ability to add departments to our MySQL database. It's going to create the departments table and this departments underscore items linking table. And that's basically what you're going to be doing for your homework, is mimicking what we're going to be doing here so that your MySQL database at home will work with our web application. So basically, let's create well, first of all, I've logged into the MySQL monitor. The database I'm currently using is the Advanced PHP database, which is our database. And if I show the tables that we have, we can see there's one table currently, items. Well, let's go ahead and create our departments table, which, as we just saw, is just going to contain a primary key column, which is department ID, and then a column for the name of the table, the name of the department. So we can write a create table statement. I'm going to call it the table departments. We're going to have the first column be department ID, which is going to be an unsigned int. It's going to be auto-incremented, just as our items table has its item ID auto-incremented. We're going to denote that that's the primary key of this table, so each department ID is going to uniquely identify a department. And then we're simply going to have a name column that's just going to be a variable length string. In this case, I'm going to set it to 25, so our department name can be up to 25 characters long. And then we close the definition, add the closing parentheses and the semicolon, and we run it. It's going to let us know that we created a table. If we run show tables again, we can see we have 2 tables in our database. To verify the structure of this departments table we just created, we can use the describe command. And we can see that our departments table has 2 fields, or 2 columns, department ID and name, and we can see all the information that we just input. So now let's create the table for our linking table. And because it's linking departments with items, we're going to be calling it, as is common with linking tables, the names of the 2 tables combined. So we're going to call it departments underscore items. The first column we're going to have is be department ID, which is going to be actually a foreign key. It's going to represent a primary key in the department table. We're going to have it match the data type of the primary key column in departments that it refers to. We're going to create the item ID column in the same way, which is going to refer to a primary key in the items table, which is an unsigned int. And then we're going to add that new sort of clause that we learned about to signify a multiple column primary key. And we're going to say that we want the primary key to be comprised of the columns department ID and item ID. Close the table definition and run it. It's going to let us know that it was okay. If we describe this new table, we can see that there's actually a column here that I haven't talked too much about when you run describe, that shows which keys are the primary key. Up here we can see in our department table that the primary key column is the department ID column is denoted as the primary key. Here we can see that primary key has been denoted by both of these columns. So in this particular table, both columns end up representing the primary key of the table. So that's how we've gone ahead and created our departments table and departments items table. That's going to allow us to basically add items add departments into our database, add items to those departments, and basically we're going to be continuing in the next upcoming lessons of migrating our departments from database from the departments.txt file into these tables. Oops. So for your homework, basically I just want you to go ahead and do what we just did. Create the departments table that's going to have a department ID and a name column. The department ID is going to be the primary key. It should be auto-incremented column, an unsigned int. The name should be a varchar, a variable length string column. Create the linking table, departments items, that has the columns department ID and item ID, which together make up the primary key of that table. So when you write that create table statement, it's going to give you some practice with adding, with signifying a primary key that contains multiple columns. And then go ahead and populate the table so that they mimic which is something we didn't do here, but you know how to use insert statements now. Go ahead and populate the table so that they mimic the 3 default departments setups that we have in our web store. And basically that is that our apparel department in our default setup contains item 1001 and 1004. Our electronics department has 1002 and 1005. Our sporting goods department has 1003 and 1006. So basically, in order to do that populate, you're going to have to run some insert statements that's going to insert information into the departments table to basically add these names. And then you're going to have to run a couple of insert statements that are going to use the department IDs that were generated when you added these departments to the departments table to add rows to our departments items linking table. And you're basically going to be linking department IDs. For example, department ID 1, you're going to be linking with item 1001 and with item 1004. And then just make sure that the foreign keys that you define in departments.items, as we went over, have the same column types as the primary keys columns that they refer back to, which for the department ID and item ID is an unsigned int. So that ends today's lesson. Thank you for watching educator.com. Look forward to seeing you next time.